In this lesson, we're exploring a couple of other conics. We're looking at ellipses and circles. And you've seen circles before, you've graphed them before in geometry a couple of years ago. So let's start by talking about the relationship between circles and ellipses. You know that a circle is the set of all points in a plane that is equidistant from a given point. We call that given point the center, and we call that given distance the radius. In an ellipse, there's two foci, that's plural for focus, and there's a center. So the center is what you see staring at you when the equation is in standard. An ellipse is the set of all points in a plane such that the sum of the distances from these points to the two foci is always the same. So if you could picture having two fixed points and a piece of string such that one end of the string is here and one end of the string is here, and your pencil is kind of dragging along, because that string is always the same length, the sum of this distance and this distance is always the same. So you would end up with an ellipse. All right. A little bit of vocabulary with an ellipse. The major axis is the axis connecting the vertices. So for example, here the major axis is this segment, whereas the minor axis is this one because it's smaller. Here, my major axis would actually be this segment, and my minor axis would be this one. So the major and minor axes pass through the center. The major axis passes through the center and the foci. Again, the book has kind of a formulaic way of looking at the vertices, the foci, and co-vertices based on the value of C, which isn't anywhere in the equation. You would have to calculate it. But I don't like to think of things formulaically, so hopefully you're able to follow along with how I describe the relationship between the foci, the center, the vertices, and the co-vertices. Here, notice, very important, because we do need to use the value of C sometimes in order to find A and B, or if we're finding the eccentricity of an ellipse, which I'll talk about later. Notice that C squared equals A squared minus B squared, and it doesn't matter whether it's oriented horizontally or vertically. Notice that the A value is always under the major axis. Okay. So let's begin. Right away, I'd hope that you'd notice that the center is 6, -3. My A value is 4, and my B value is 3. So what does that mean in the context of the graph? Well, let's plot the center, 6, -3. So there's the center. Notice how my A value is under the Y. That means that from the center, I'm going to count up 4 spaces, 1, 2, 3, 4, and I'm going to count down 4 spaces, 1, 2, 3, 4. These are my vertices. The B is how many spaces away from the center my co-vertices are. So from here, 3 spaces to the right of the center, 3 spaces to the left of the center, and connect the dots. And there's our ellipse. Not the prettiest thing in the world we've ever seen, but the most important thing is being able to identify the center, identifying what A and B are, and eventually being able to calculate C in order to find eccentricity. In this equation, oh my goodness, the equation isn't in standard form, so we have to get it there. And once again, we're going to have to complete the square in order to accomplish that. So let's get all of our X stuff together, all of our Y stuff together, and then bring the loose number over to the right-hand side. So I'm going to rewrite this as x squared plus 4x plus blank, and hopefully by now you know that that blank is for the number that's going to complete the square, plus 4y squared minus 40y plus blank, and then equals negative 103. To complete the square, remember I'm going to divide this term by 2 and square it, so that'll be 4. So I know I'm going to want to add 4 to the other side of the equal sign. This, however, is made uglier than it needs to be because of this 4 in front of my y squared. So what I'm going to do in the next step, I'm going to go ahead and rewrite the next step having this as a binomial squared. So this will be x plus 2 quantity squared plus, and I'm going to factor the 4 out of this expression. So now I have 4y squared minus 10y plus whatever that blank is equal to, and this is negative 99 now. But I have to figure out what I'm adding here. So remember, you take this term, divide it by 2, and square it. So 10 divided by 2 is 5. 5 squared is 25. But whatever I do to one side of the equation, I better do to the other. Keep in mind, however, I did not actually add 25 to this side of the equation. I added 100 to this left side of the equation. So that means I better add 100 to the right-hand side of the equation. Now I have x plus 2 squared plus 4 times the quantity y minus 5 quantity squared equals 1. Now under normal circumstances, I'd probably have a number other than 1 over here, and then in order to get the 1, I'd divide the whole equation by that number. I already have the 1 here. So what's kind of vexing here is how do I rewrite this so that it's x squared, or x plus 2 quantity squared over something? Well, that's easy enough, over 1. But how can I rewrite this so that it's y minus 5 quantity squared over something? Well, I take the reciprocal of 4, and that's what I put y minus 5 over. So my new equation in standard form is going to be x plus 2 quantity squared over 1 plus y minus 5 quantity squared over 1/4 equals 1. So that means that the center, let me zoom back out, the center of this graph is negative 2, 5. My a value, so I plot my center, negative 2, 5, 1, 2, 3, 4, 5. And horizontally, I'm going to go one space to the right and one space to the left. Vertically, I'm going to go half a space up and down from that center. And this is my ellipse. In the next example, we're writing an equation when we're given the set of characteristics. So we're given the foci. Remember, the center, notice, is the midpoint of the minor axis. It's the midpoint of the major axis. It's the midpoint of the segment connecting the two foci. And again, that holds for no matter whether it's a vertical or a horizontal ellipse. So, first thing I'm going to do is find the midpoint of the segment connecting the foci, because that is my center. And remember from way back in geometry that you find the center or the midpoint of a segment by averaging the x's and averaging the y's. Notice that the y's are the same, so we know what the y coordinate is. We know that it's going to be 3, but we're doing 19 plus negative 7 over 2, comma 3. So 19 plus negative 7 is 12. 12 divided by 2 is 6. So my center is 6 comma 3. So that takes care of the numerators of my fractions in the standard form of the equation. Now I've got to find the denominators. Because this is, well, let's kind of sketch this out. Remember, I don't like to think in terms of formulas. I like to think of things conceptually, and I think that's more important than a couple of formulas. So if my foci are at 19 comma 3 and negative 7 comma 3, then they'd look kind of like this. And since my foci are on this horizontal line, that means that I can think of this as a horizontal ellipse, meaning that my major axis is going to give me an A value that's going to be under the X. So let's kind of break this down. I know what my numerators are going to look like. They're going to be X minus 6 quantity squared over something plus Y minus 3 quantity squared over something. Remember that the major axis connects the two vertices. Okay, so from vertex to vertex, it's 30. Cut that in half, that's 15. Square it, and that's your A squared value going under this X stuff. Okay, so half of 30 is 15. 15 squared is 225. So that's here. Now I got to figure out what my B value is. Well, just how I figured out what my A value was and squared it here, I can use the distance between the two foci to find my C value. Okay, so the foci are at these two spaces. So how far apart are these two foci? From 19 to negative 7, that's 26 spaces. So if I take that 26 and cut it in half, I get 13. So C is 13. Remember that C squared equals A squared minus B squared. C squared is 169. A squared is 225. Solve for B squared. B squared, therefore, is 56. And remember, B squared is the number that goes here. So there's our equation. Part B, this time they've given us the coordinates of the vertices. Remember, the midpoint between these 2 points is our center. So the center, notice how the x-coordinates are the same, so I know its x-coordinate is also going to be negative 2. And I take the average of negative 4 plus 8. So negative 4 plus 8 is 4. 4 divided by 2 is 2. That means that my center is at negative 2, comma 2. So I know what my numerators look like. Let's go ahead and get that out of the way. X plus 2, quantity squared over something, we'll figure it out, plus y minus 2 squared over something that we'll figure out equals 1. Now we know the length of the minor axis equals 10, so that means that b equals 5 and b squared is going to be 25. So I know one of these numbers is going to be 25. It's going to be the smaller one. So maybe I want to figure out whether this is a vertically oriented ellipse or a horizontal one. So consider these vertices. If these are my vertices and I kind of just sketch this out, negative 2, negative 4 would be down here, and the other vertex would be up here. So this is a vertically oriented, which means the larger number goes under y. I just figured out that my smaller number is 25. That goes here. And then the larger number, I can find that by taking the difference, the distance between the vertices. So how far away are these 2 points? Well, the points, or the x coordinates are the same, so let's look at the y coordinates. They are 12 spaces apart. Cut that in half, and that's 6. 6 squared is 36. I mentioned eccentricity earlier. Eccentricity is a value, we call it E, and it's always between 0 and 1, and it's the ratio of C to A. So we've talked about the relationship between C and A. Here, we're given the equations. Got to figure out what C is. C squared equals A squared minus B squared, so 48 minus 18, which is 30. So C is the square root of 30, which is approximately, and I don't have to worry about simplifying a radical, so that's good news. The square root of 30 is 5.48 approximately. So the eccentricity is 5.48 over A. Now A is the square root of 48. So when I take that 5.48 and divide it by the square root of 48, I get approximately 0.79. And that's it. So notice how here I mentioned to you that if the value is closer to 0, then the ellipse will be more circular. Okay, so this is going to be not quite circular because it's not 1, but it'll be a little bit fatter of an ellipse. It's not going to be very narrow. Let's consider this one. C squared equals A squared minus B squared, so that's 2. So C is the square root of 2, and that means my eccentricity is the square root of 2 over the square root of 19. So in your calculator, you evaluate that. And you get 0.32. So even without graphing these, I know that this is going to be a skinnier, narrower ellipse than this one. Now, for some reason, I forgot to copy and paste this formula out of the textbook onto your notes, but hopefully you remember it from geometry. In the last example, we're trying to figure out what kind of conic an equation is, since none of these are in standard form. So let's start with part A. In part A, I would hope that you'd notice right away that it's going to be a parabola, because only one of my variables is squared. But we do still have to go through the process of writing the equation in standard form. So let's do that. Let's get all the y stuff on one side and everything else on the right. I have to complete the square here. That means I'm going to divide 6 by 2 and square it to get 9. So I'm adding 9 to both. I factor the 3 out, get 3 times x minus 1 equal to y plus 3 quantity squared. And we already said that this was a parabola. In part B, I have x squared stuff, y squared stuff, x and y stuff, and a loose number. So I'm going to get my x stuff together, my y stuff together, and bring the loose number over to the right. That'll be 4x squared minus 24x plus 4y squared plus 32y equal to negative 36. Conveniently, and I hope that you would notice, Everything is divisible by 4 in this equation. We've already talked about how that makes things easier for us later, so we want to make sure to make things as easy for us as possible. So we're going to divide the whole equation by 4. That gives us x squared minus 6x plus y squared plus 8y equals negative 9. And I need to complete the square. So I have x squared minus 6x plus a blank plus y squared plus 8y plus a blank equal to negative 9. Then I'm going to add stuff to when I figure out what these blanks are. Negative 6 divided by 2 and squared is 9. 8 divided by 2 and squared is 16. So we have x minus 3 squared plus y plus 4 squared equal to 16. And since there's no number in front of either of these, or rather, more to the point, since the number, if we think of that 1 that's there, since that number is the same, this is a circle. Last one. I have x squared stuff, no x stuff, so I only have to complete the square once for the y. So I have 4x squared plus 3y squared plus 36y equals negative 60. I'm going to factor the 3 out of this y stuff to make my completing square process a little bit easier. So y squared plus 12y plus blank equals negative 60. In order to complete the square, I take this 12 divided by 2 and square it. That's 36. But again, remember, I didn't add 36 to this side of the equal sign. I added 36 times 3, which is 108. So that's what I need to add to the other side of the equal sign to keep things in balance. Now I have 4x squared plus 3 times the quantity, y plus 6 squared, equal to 48. Since this number and this number are not the same, I know that this is going to be an ellipse, and in order to get the equation in standard form, that means I need to divide this 48 away. So divide everything by 48, and I get x squared over 12 plus y plus 6 quantity squared over 16 equal to 1.